Let's take a look at a product that we've had for a while now that I don't think gets as much attention as it deserves. This is the thermal printer. Now, a thermal printer is what you would find in a receipt printer. So if you get a receipt from a grocery store or fast food restaurant, it's that sort of waxy feeling paper, and the way that it prints is actually thermal. So it has a print head that heats up and causes the paper to change colors, as opposed to an inkjet printer or a laser printer, which actually deposits ink on the surface of the paper. The advantage to that is that you don't ever have to change any print cartridges. The disadvantage is you do have to use special paper, but because it's used in receipt printers, it's pretty ubiquitous and you can get it at most office supply stores. All you have to supply this printer with in order to make it work is a 5 to 9 volt power source that can give it at least 1.5 amps. Because it is heat-based, it draws a little bit of current when it prints. Also, you need a data line, and the data is just a TTL serial connection. You can connect it directly to an Arduino. Arduino serial will drive it fine. And then there is a library that's available from builder.org that will allow you to communicate with the printer the same way that you would communicate with any software serial device. So you just tell it which pins the printer is on, and then you pass .print or .println statements, and it comes right out on the printer. This printer can actually do a few things besides just text. It'll also print very low resolution bitmap images, as well as generate and print barcodes in code 39, I believe is what it uses. What I've done here is I've constructed a demo using the thermal printer, and it's my legit scientific chart recorder. Now, a chart recorder, for some of you who may not be familiar with it, is a lot like a multimeter, except it records all of the readings that it takes along the way on a piece of graph paper so that you can mark the graph paper, you can write down times on it, and you can sort of analyze the output of a sensor. So all I have here is a couple of potentiometers which set the scale of the incoming signal. So all it does is sort of scales from 0 to 5 volts, or you can scale it down to reading like between 0 and 1 volt, something like that. And then I have an interval dial, which changes the speed at which it's updating the measurements. Now, obviously, if you have the interval set super high, the printer won't be able to keep up and it'll just sort of spit out all the paper, but I have it set at sort of a middle ground right now. I have a couple of LEDs. One LED just tells me that the power's on. The other LED shows me what the interval is by blinking every time that it takes a reading. And then I have 3 channels right here. And this is a ground rail, and then these are just inputs, and they're connected directly to the analog inputs on the Arduino. It's a breadboard, so same thing as an Arduino Uno, in the box, running everything. And then I have one of our 5 volt, 2 amp wall wart power supplies driving the printer and going into the raw power in on the Arduino. To show you how this thing works, I've hooked it up to one of our sharp distance sensors. This is just an infrared distance sensor, and I have power going to that from a Cerberus cable. And then I have the channel 1 input connected to the signal out on the IR, and then I have another ground connected with the ground for the power, so that you have a common ground. And now, if I plug in the chart recorder, I should start to see readings on the paper that correspond to the distance of my hand from this sensor. As you can see, the thermal printer is printing an asterisk on the far left-hand side of the receipt paper. But as I move my hand over the sensor, you should be able to see that the asterisks are actually moving around the paper in response to my distance from the sensor. And I'll actually turn up the interval a little bit so you can see what's happening. There we go. Closer. And farther away. And closer again. So as you can see, you can keep a record of what this sensor is getting. And then at the end of your data collection, you can simply turn the chart recorder off, and then you have a graph of the history of that sensor's readings. So that's the legit scientific chart recorder and the thermal printer. If you have a project where you need to print out a little slip of paper, maybe it's a take a number style ticket dispenser, or maybe it's a really low resolution photo booth, this is the perfect thing to embed into your project. And like I said, the paper isn't expensive, it doesn't need ink, it's a pretty cool little device.